I'll start the recording. Continue. All right. I was a little bit in family situation. I just came directly from home today. My daughter is sick. Anyway, let me try to open this. Okay, perfect. So, what did we do last time? What did we learn in last time? Tangential and normal acceleration. We did how many math problem? Two, right? Two math problem. There was another one in my note. I felt like it's not probably that much important for me to deal with the same thing again and again because I have so much to cover. The topic for today is relative motion. Okay, the relative motion and the tangential and normal acceleration. Those things are in homework number 3. Anyone of you started doing homework number 3? Not yet. So homework number 3 is in bright space, obviously, and forgot the deadline. Most likely, sometimes in next week, right? I don't know. I have time or plan to even give you any hints on that today. I'll just simply start with relative motion. You know what means relative motion? Any idea? Say like I'm walking, Brett is walking. So with each of us have different velocities, maybe. So then we can compare like what would be the relative motion of mine in terms of Brett's. Does it make sense? So that's called relative motion. So many practical applications. Like uh, one application could be given is like say like I mean in a sports say like a ball is thrown with certain velocities a person or the player is running catch the ball, so the ball is running, player is running, so what would be the relative motions in between them, right? The application I'm talking, thousands of application could be explained like if a ship, cargo ship, big ship like running like the aircraft, right? Aircraft is on the runway moving, ship itself is moving, what is the relative motion? Okay, so those are some of the very practical applications, and you'll be seeing some of the applications as well as in the math problem that I'm planning to do today. Okay, in homework you do have some practical application as well. Any question? You understand relative motion? I will definitely know what is relative motion. Now I'd like to see it, obviously, right? Okay, so let's start with the theory first. Okay. By the way, this material should be in Brightspace. I uploaded a bunch of materials. It has like so many materials along with whatever I'm covering, extra materials as well. Okay, in case if you're wondering what these things brings to be fine. So obviously, there's another application that we're seeing. A car is moving, right? Means car is on driving condition and the rain is falling. Did you guys ever notice that when you drive at interstate, it feels like suddenly maybe the rain is too fast? You guys notice that? But probably you are just coming off to the ramp and immediately you're not seeing that much fast raining happening. So why does this thing shows this way? Obviously because your speed is much higher in highway, right? Or in interstate. That's the reason you're seeing the rain is coming too fast. Actually rain is falling to its own speed, right? The same speed in the exit, same speed in the highway. But because your speed is higher, so you're seeing the relative speed is a little different. Okay, so that's kind of the same application here, and the another application is in the side. Okay, so to understand it theoretically, so like you have these two different, I mean, you can deal with this relative motion three terms: position, velocity, and acceleration, just like any other places, right? So let's deal with this relative motion in terms of the position, right? Because the position is also relative as long as there are two motions are active. So like you have this a object which is moving and this b a object which is moving as well. Now what would be the relative motion, I mean position change in between those two? Okay, now in terms of the position, anytime you'd like to define a position, it needs to be in certain axis, right? Like Cartesian, cylindrical, spherical, whatever coordinate system you have. In this case, assume it's a Cartesian coordinate system, right? So Cartesian coordinate system x, y, z, and your origin is here 0, 0, 0. Okay, so position for this first object A would be what? Like based on this zero, right? And if it's a 3D case, it should be what? I already remember x comma I x I plus y z plus z k. You remember that I j k is the unit vector, right? that's how we can define this position A, right? Same way we can define this position B. It will be, instead of, if this is x1, y1, z1, this should be x2, y2, z2. Does it make sense? Okay. So your R and RA and RB would be the position vector. Remember, that's how we're gonna define. So let's write this RA here. And anytime you have a vector, you'd like to put a line on the top, RV here, right? Now here's the thing. These are those two positions based on the origin O. You understand that? And R means what? R means A. If I'm gonna assume, say it would be XAI, okay, YAJ, ZAK. Everybody understand what I just did? Okay, so then RB can be written as similarly, right? XB I YB J ZBK. I, J, K are obviously unit vectors, right? So now I was just talking about what is the relative position, and now we're dealing with the position vector from A to B, right? How are we going to define that? You can write this. Okay, the relative position of A with respect to B. Different way they say that, but this is what you can define. Okay. Now you guys remember from statics, like the triangle rule, force triangle. Okay. So in force triangle, you remember, like if it's a vector, right? This RB here seems like a resultant, right? And this one RA and RBA seems like going kind of the same direction, right? So can I write this? This one plus this one is equal to this one. That's from the statics, right? Force triangle, different thing you have done over the years. So let me write that. So you have this RB equal RA plus RBA. This is a vector. I just wrote it in terms of vector, right? Now, when you'd like to add them, you might have different values for XA, XB, YA, YB, ZA, ZB, right? And then I, J, K are unit vectors. You can kind of like manipulate them, like putting the I, and then in the parentheses, like XA minus XB, something like that. You understand? Mm-hmm. All right. So maybe like you'd like to see an example, right? Let's deal with an example. Say like we're dealing with a 2D, not 3D, right? So this is an example. Example for a 2D case, okay? So you have this RA, assuming is given as 3I, 6J, and RB is given as say like 6I, 2J, okay? So can you find the relative position of A with respect to B? Just the thing that I was explaining. Can you find that value? I'm leaving it to you. I'm giving you the answer though. It's 3I minus 4J. Whenever you have the value, let me know. If you're struggling, let me know. I'll come and help you in person. A little bit of thinking you need to do, right? Obviously, you have this RB equations as given. Have to rearrange that equation, right? I'd like to say, okay, this is your equation number 1. Hint would be rearrange here. So rearrange equation number 1. Okay? I'm putting the arrow here. Rearrange it. Okay? So you can find RBA, which should be RB minus RA, right? All right. So then plug the values now. Is the cat. How are we going to do that? You should have, I said like, what is the answer? 3I minus 4G. How many of you got that? 1, 2, 3. Anybody else? 4. 4 of you got it already. I'm giving you a little bit more time. This could be a good practice. First thing first, that what I was saying, like, from equation 1, you can write this as RB minus RA. So what you should be doing, you have the RA and RB value. You should be putting this I, and in the parenthesis, you should be putting J, and in the parenthesis, you should be writing whatever the X coordinates. So like here, this is your X coordinate. So this is your X coordinate. Let's do a color code. So you'll have 6 minus 3. So this is my color code, right? Hopefully it doesn't make any sense. And then let's do another color code, I guess, with this one. So say like this is your so this is your 2 minus 6, and then I'm doing the color code again. Okay, does everyone understand this? Everyone got the value that I was talking? Perfect. I'd like to move on now. So this would be 3i minus 4j. Good practice. So relative position, and you probably already understand back of your mind that you got to do it for relative velocity, relative acceleration, right? This kind of goes in the same way. Everybody? All right, perfect. So then those things can be, I'd like to rewrite this way. So like RB, okay, just equation 1. I'm writing equation 1, okay, in case if you're wondering. Let me write it here. So equation 1. So RB can be written as RA plus RBA, okay? Now, if you agree with me on that one, that's equation 1. I didn't do anything new, just rewrite the equation 1. Can you simply do the same thing for the velocity and the acceleration as well? Okay, so do that. That could be a good practice for you. So it should be what, like VV. There's a typo. I hate to do typo. So BVVA plus VVA. Now don't forget to put a line on the top because those are vectors, right? Because it does have ij and k components if you're dealing with the Cartesian coordinate. So the same thing is for acceleration. You know, A means acceleration. All right, so that's pretty much the theory. And I do have math now. Giving a little bit more time, okay, to finish the theory. I hope after today's class, you should be able to deal with the homework pretty comfortably. Homework number 3, that's what I'm talking, right? And we'll talk probably a little bit on Monday. And I don't know, the deadline is Monday? So end of Monday, you can submit it, right? If you have any issue, like, you know, we can talk about it as well, the homework. And a new one, I'd like to upload it in. I think there is an exam that I announced in last class, right? See that? Yeah, so next week we'll be doing exam as well. Week 4 is gone. See how time passed? Very fast, right? Before even you realize, spring break will come and the semester is going to end, and sweet summer is going to come. All right. I feel like today's summer. Do you see the temperature? What is the temperature today? 23 or something, and it feels like summer to us because minus 20 or something happened in Waipunicaco. Oh man. 27. Yeah, it's like 27. It's summer then. It's definitely a summer, 27. Right. I'm here almost 10 years. I'm now like North Country people, you can say. Anyway, so moving on here on this topic. All right, here we are dealing with the aircraft, and the same example. Remember the application I was talking, right? The what do you call this thing? Like, you know, a big ship. I don't know if the aircraft carrier. Yeah, we can say it that way. Aircraft carrier, and it's not necessarily just stay somewhere in the ocean. It's always move. It's probably always moving, right? So if it's moved, it does have a velocity. Aircraft needs to land and needs to take off, so it does have its own velocity as well. So relative velocity is there for sure, right? So that's the problem is all about. Let's see what they say about this problem. So it says here an aircraft carrier is traveling forward with a velocity of 60 km per hour. Okay, I believe it. So it does have a velocity of 60 km. Just 1 second. Can I? It's important. I gotta take this call because My son is babysitting my daughter. My son is calling. Hey, I'm in the class. Okay. Okay, I'm in the class. Bye. I'm extremely sorry. I I thought that something emergency happened. Um, okay, it's just talking about the problem itself, right? All right, I was talking about the velocity, right? Okay, so aircraft carrier, that's what I was trying to say, has a velocity of 60 kilometer per hour. At the instant shown, plane A has just take off the end of the carrier and has a forward horizontal velocity of 250 kilometer per hour. Okay, measured from still water. Okay, the actual velocity of this guy here is 250 kilometer per hour, right? All right, and the aircraft velocity for this one, it's moving to a certain velocity like 60 kilometer per hour, right? So those two velocities are given so far. So if the plane B is traveling along a different runway to the carrier in the direction shown at at this 30-degree, okay, so basically what is happening here, this aircraft A is moving along the direction of the aircraft carrier, and there is this runway which has an angle with aircraft 1, which has an angle with aircraft 1. What is an angle? It is a 30-degree angle here. So that's for aircraft B, and that's for aircraft A. Two has two different speed, like one is 250, another is 200. Everybody's following, right? All right, perfect. So then once you have those, these two different velocities, right? Here's the thing. You have this carrier can be written as C, okay? And it does have its own velocity. So if you're gonna assume like out of this top line, this VC is somewhere up to this, okay? The reason I'm saying that, take a look here. This speed, this 250, it's when it's just take off, right? From the end of the carrier, right? So that's why if I'm gonna assume that, and then I'm gonna do a direction just like my A aircraft has a direction towards X direction, and Y is just perpendicular with it, okay? And let me start writing what is given. So your givens are here, that VC or carrier velocity is given as 60 kilometer per hour. VA is given as 250 kilometer per hour. VBC is given as 200 kilometer per hour. Okay. So again, let's try to focus on this thing here. So it says here, let's try to understand. If plane B is traveling along a different runway of the carrier in a direction of 200 kilometer per hour, that's what the catch is. Okay. So what does it mean? When the plane B is still on the runway, it has the relative velocity because VC or the carrier does have 60 kilometer per hour. It makes sense? So the velocity that you're seeing is the relative velocity. Okay. So that's why I wrote here B/C. It doesn't make sense. So the velocity of V with respect to C. Okay, that's what it refers to. Velocity of V. V is what again? V is the second plane, right? Or second aircraft. So velocity of V with respect to C is 200 because that's what in the question they gave you, right? The question, yeah. And for the velocity for the aircraft A, they said like 250. It's like when it's already take off, right? That means it's on the air. So that 250 with respect to water, not the carrier anymore. Is it clear? Just try to understand those. And VC is the carrier, right? Like the whole ship. The ship has 60. That's why those are named this way. Okay. All right. So then you wanna draw this draw this direction, which would be VBC. So velocity of B with respect to C, as if like try to visualize. It is little complex. So like X direction, the aircraft is moving, right? Aircraft is moving this way. On the top of me, right? Say like a fly or an ant is running so fast, it has its own velocity. But that fly or that thing that was ant was saying, that was moving in an angle like this. Make sense? So the relative angle would be it should be like this, rather. It should be like this, right? It should be something like connecting from this to this. Make sense? So that's why your BC is like that. Everyone understand that? It's not difficult to initially understand, or at least visualize for sure, right? But BA is clear, right? BC is clear because this is on the same plane. This is my X plane. Again, that's my assumed plane, not necessarily X is written somewhere along this line, right? Okay. Everyone understand everything on the image so far? Okay, let me know if not. Okay, so the final thing that I'd like to draw another relative velocity, okay, which would be connecting the top two, which would be VA with respect to B. And you can just forget about what I did in the middle, right? So you have this VA and you have this VB. So that is connecting the finished part of those two arrows. So that's why is velocity of A with respect to B. Okay. All right. So if you understand everything, what I draw over there, so find. So BAB. So let's focus on that with respect to this. Determine the velocity of A as seen by pilot plane B. So that's what they're asking. Find BAB. Is it clear to everyone? Determine the velocity of plane A. So that's my A. Let's try to do a color code. So determine the velocity of A, right? So I have this A here, okay? By the pilot of plane B. So that's my B. Okay? Clear so far? So, okay, so that's what we are trying to find. And you'd like to find this BB as well because they didn't give you the BB. Okay, why I'd like to find BB or the velocity of aircraft B, because you see the VAB or the velocity of A with respect to B requires BV value. Does it make sense? All right, that's the reason you got to find that. Okay, and how I am saying that, just would like to write a little bit more. So say like the solution is happening here, right? And let me put some strategy. So say like BAB is obviously BA minus BB. Now you don't have to see the sketch or anything to write that. Anytime you have VAB, that definitely refers to that, what I just wrote. Everyone understand? VA minus VB, okay? So now that you have the value of the VA, obviously you are after the VB, right? In order to solve this. So let's put it as equation number 1, okay? And then to find the BB, that's what the challenge is gonna come. To find the BB, take a look here. And then I'm gonna, I don't know, maybe just highlight only this triangle. Everybody see my highlighted triangle? And I'm trying to find the BV. And then take a look here on the highlighted triangle. So I have this BV. It should be equal to VBC plus BC. Is it clear to everyone? Oh, that's not true. Let me do it a little bit different color. So I have to add this to find this BV. It's showing up now? Okay. So then I do have to add BC plus BBC. Okay. So now probably you'd like to understand a little bit more. So this is gonna be plane B with respect to, so sorry, so with respect to WRT, that's the short form of that, to still water. Plane V velocity, VL dot means velocity, right? That's your VB. All right, and this term you might be wondering how should be writing. It should be plane B with respect to carrier C. Is it clear to everyone? Everyone understand? Perfect. So if you understand so far what I just said is just simply doing the math, okay? And before doing any of this, you gotta put those in terms of I, J, K. And it's a 2D case, right? Think this way. If it's a 2D case, then K is not there. And if I'm gonna write this, okay, I'm gonna put, first of all, this is equation number 2. I'm gonna write this in X and Y direction, right? Just 1 second, sorry. Technical glitch. All right, so you see, you have this X and Y direction. You have this X and Y direction, right? So let's try to write those in terms of I and J. You guys remember, right? X, in X direction you have unit vector I, and Y direction you have unit vector J, right? Okay, so if you are with me so far, so can I write this BA is in X direction, right? Is 250 I. Can I write that? Unit I is the X direction, right? Everybody agree? All right, so then can I write this BC? It's also in X direction, right? It is 60 I. Can I write that? Alan, can I write that? Because both are in X direction, you understand? The carrier is moving in X direction. That's your assumptions though, right? Okay, so then can I write that this would be tricky. So BBC as 200 cos 30, okay, I plus 200 sine 30 J. Now remember, carrier and plane B runway, carrier movement and plane B runway has an angle of 30. And using that, I can write this BBC, right? BBC as 200. What is the 200 again? The 200 is given as here, like the velocity of aircraft B with respect to carrier C. Does it make sense? So that 200 obviously has X and Y component because it does have an angle, not in X or Y directly. So how to find which component? Like, always X component will be cos theta. Theta is 30 given, right? And Y component is sine theta. Just think that way. Is it clear? But it should be shown in the figure as well in terms of geometry. All right, so after that, it's just simply doing some manipulation. So you should have this value should be, let me rewrite it. So this value should be 173.2 I minus 100. Is it 100? It should be 100. Huh? Yeah. It's 0.5. So now you have pretty much all the values. Can you do that from equation 2, right? Can you find BB? You have the BC and BBC. Can you do that, everyone? How going to do that? Obviously, you just simply need to plug all the values. You have this BC is given as 60, right? 60C, 60I. and then you have this BBC 173.2i plus 100j. Can I write this as like simply adding like the I component? You know that, right? How to do that? Adding the I component, which would be 233.2i plus 100j. That's your VB. And you can at this point start to put some unit here, right? Actually, you should be putting units pretty much everywhere. You can also put the unit here, kilometer per hour, kilometer per hour. This is also kilometer per hour, right? This is everything is kilometer per hour. So you should be start putting some units as well. And then once you have the BV value, then what do you want to do? You want to write this equation number 1, where you have this BAB, which is the final thing that you need to find, is BA minus BB. And then, you know, your VA value is what, like 250 I minus 233.2 I. So plus, it will become minus. Let's do plus for now. J. This whole thing is inside the parenthesis. And then if you're going to do the math further, you're going to come up with, you can do the math, right, everybody? So it's just simple manipulation. Let's see if we can do the math. Okay, let's see what is the I value going to get. What is the J value going to get? What is I value get?
16.8.
Yeah. And J?
The negative.
Negative 100, right? So obvious. Everybody got it? I to I needs to be manipulated. You have one I here, another I here, right? I means in X direction. I say unit vector in X direction. And J is in Y direction unit vector, right? So you should have that value that what Logan says, 16.8 I minus 100J. And don't forget to put the unit, kilometer per hour. And that's the velocity, right? They forgot to put a line on top of the V. That's the velocity of aircraft A with respect to aircraft B. You have to understand the aircraft B is still on the runway, right? Aircraft A is in the air, right? So tricky to understand the whole problem. Take a look here. See, the BV, or the aircraft velocity for aircraft B velocity was not directly given. What was given? The aircraft velocity of B with respect to carrier C. That was given. Okay? So that's why understanding this problem is very important to understand the whole relative velocity concept or everything. Any problem related with that, you're going to understand it, right? You just have to focus on the force diagram. As long as you understand that force diagram or velocity diagram in this case, then it should be good. That position diagram, force diagram. Force diagram is the acceleration diagram usually. So come back to this point when I was saying, like, you know, they gave you three things basically. One is the velocity of aircraft A with respect to still water, velocity of the carrier itself, you see, and the velocity of the aircraft B with respect to C. C is here the carrier. Okay. So now to find the velocity of aircraft A with respect to velocity of aircraft B, you need to find the actual velocity of aircraft B, not the relative one. They gave you the relative velocity of aircraft B, right? Respect to C. So we gotta do the manipulation or velocity triangle manipulation to figure out the actual velocity of the aircraft B. Once we have that, just simply manipulate this to find it. Any question? So relative velocity concepts are usually a little tricky to understand always. I do have another problem. I have 10-ish minutes left. I don't know if I can finish it. Let's try. Let's give a shot. And the third homework that you're doing, the fourth homework is something related with pulley. You guys did in statics pulley, right? So just to give you a heads up what is happening. All right, so the ship, a ship travel at a constant speed of Bs is 20. Okay, so the Vs is 20. As for ship, 20 meter per second. The wind is blowing at a speed of W refers to wind. Bw is 10 meter per second. That's the wind velocity. Okay, and they gave you the angle of wind velocity with x. Say like this is x, right? And then they gave you the angle of the ship that ship movement direction is that 45 degree. Okay, two angles are given. Determine the magnitude and the direction of horizontal component of the velocity of the smoke coming from the smokestack as it appears in the to the passenger on the ship. All right, see the smoke is coming from the smokestack, right? There's this stack, this is coming here, right? So the question is asking, okay, find the direction of this smoke. Okay, let me focus on that. So find the direction and the magnitude. So they said this, the magnitude and the direction of the horizontal component of the velocity of the smoke. Okay, so it does have two components, right? Like, you know, x component and y component, right? So it's asking about the x component of the velocity of the smoke. If you understand, what does it mean? Everyone understand the problem? It's again relative velocity, because you see the wind is moving to its own velocity, the ship is moving to its own velocity. Now the smoke is coming from the ship. Smoke is coming from the ship. It's supposed to be the ship velocity, but it is not going to the ship direction because the wind is moving that smoke direction to a certain angle. Okay, so both the ship velocity and the wind velocity has something to do with the smoke velocity, smoke moving direction. Is it clear to everyone? Okay. So let's see, let's start with the givens. So the givens are, the ship velocity is given, obviously. Let's just put Vs just like the way they did. It's 20 meter per second. And then they give you the velocity of the ship is 45 with x, right? All right, so that's what the moment of the ship direction. Okay, and then you see this, because of this 45 angle, 20 meter per second can be written as two component x and y, and this one would be very straightforward, cos 45 and sin 45. And why do I do that? Remember, just like last problem, would like to get x and y component to get I and j direction. Are you with me so far? What I'm doing, like I'm just making the component of the velocity of the ship in x and y direction. Same thing I'm doing for the wind velocity. Okay. All right. So far nothing fancy, and the wind velocity is given as 10 meter per second, right? With the direction of 30 degree. Okay, with x is here. So that can be written as, yep, cos 30 VW, which is 10 by the way, or you can write 10 here, I degree minus, why do you have a minus? Anyone? Yeah, it's negative y. Okay, sine 30 j. This w doesn't look perfect. Let me try to rewrite it. Okay, so w means wind, right? That's what subscript is referring here. Obviously, then once you do the math, you're gonna have a value of 8.66 I minus I think it should be 5j. Okay, and you'd like to put the unit as well next to it. So you're gonna find the horizontal component. So let's start with the find. So we're trying to find the horizontal component of smoke from the perspective of passenger. So you have to do one tiny assumption. It is like the horizontal component matches with the wind. So that's the assumption. In other words, this V smoke and V wind is the same. Okay, so all right, so the solution. So V wind shape, V wind shape. So you are trying to find the x component of the smoke with respect to wind. Okay, so once you have the wind, and you do have the wind and the ship x and y component, right? We'll just simply plug those values and then find just the x component of that. Okay, I'll talk more about it in next class. We are almost at the end of the time. Don't want to focus too much on that. So let me quickly give you the result, 8.66 I. In the meantime, you can think about it a little bit more, meter per second. You have this 14.14 I plus 14.14 J. Oh, by the way, this is, by the way, for ship. This 14.14 I, 14.14 J. That's for the ship. Okay. All right. So then you have those things in meter per second. And if you're gonna do the math, you're gonna have the value of minus 5.48 I minus 19.14 J meter per second. Now the question is asking, what is this value? Okay, the x component. And as I said, like we are running out of time, so I can talk more about it in next class. But as a bottom line here, so they gave you the ship velocity, they gave you the velocity of the wind with some angles for both of them. We found the components for both of them, like the both velocities in x and y direction. And then finally we found the smoke x direction. Okay, so we found the relative velocity of the smoke with respect to wind, and from there we find the x direction. Okay, because I and j, I is the x direction velocity. Okay, you know that. Any question so far? All right. Okay, I'll see you on Monday again. Yes. Yes, tell me.
I'm kind of just wondering what made you choose the VW over the VS first?
So here the question is asking. So the velocity of the smoke coming from the smoke stack as it appears in the passenger on the ship. Okay, so the smoke is actually, when it come out, it has a relative speed with the wind, because it's not a material itself. So
Yeah.
that's the reason. You see, your assumption does have that. Okay. So horizontal component matches the wind speed of the B smoke BW. So that's the reason you are doing the speed with respect to wind, not the ship.
Not the ship.
Yeah. You do have the ship here initially, the wind and the ship. Okay, but because the smoke is wind, so that's why you see this is actually smoke. That makes sense?
Yeah.
It's a little tricky.
Yeah.
Yeah, that's what the assumption is for. Yeah.
Let me check this out.